Okay, so we have spent a lot of time talking about naming ionic compounds. Naming molecular compounds is much easier because we don't have to worry about charges and whatnot. So the first thing is, the only type of molecular compounds we're going to name are called binary molecular, which binary means two nonmetals. So the only compounds we're going to name as binary molecular or binary covalent are two nonmetals bonded together. So going from the formula to the name is very simple. You look at the name, you look at the formula, you name the first element first using the name of the element. You name the second element second, and you change the ending to IDE just like you do with ionic. And then you use a prefix in front of the name of each element to indicate how many of them are there. What is the subscript? Where these prefixes come from are your prefixes that you use in geometry. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So you will need to know these 10 prefixes and what the prefix is and how many it refers to. So let's run through a couple of examples of this real quick. Go back one where I have a little more space. So let's say I want to name the compound that has the formula P4O10. So what I would do is name the first element first. The first element is phosphorus. Okay. The second element is oxide, because it would be oxygen changed to IDE, oxide, just like when you have ionic compounds. Now, since there are multiple atoms here, I have to tell you how many of each there are. Phosphorus has 4, so I would put the prefix tetra in front of phosphorus. There are 10 oxygens, so normally I would use the prefix deca, but since it's 2 vowels in a row, I just use dec, I drop the A, so this would be tetraphosphorus decoxide. That's really all you need to know. The only thing that is a little bit different is if you have only one of the first element. So if I have one of the first element, I would have carbon. I don't normally put mono, I don't ever put mono in front of the first element if there's only one of them. So this would be carbon. There are 2 oxygens, so di, and then oxide. So mono is not used as a prefix for the first element. However, it is used for the prefix of the second element, because I have a related compound called, that has the formula CO. That would be carbon monoxide. And again, I'm dropping one of the O's because you wouldn't put 2 O's in a row. So the mono prefix is in front of the second element, but it does not go in front of the first element. Other than that, use prefixes for everything. So looking at this, if you have to go backwards, if I give you a name and you have to write a formula, it's pretty straightforward, because all you're doing is looking at what the prefixes are and what the symbols of the elements are. So for example, dinitrogen pentoxide. That's the name. So dinitrogen means 2 nitrogens. Pentoxide means 5 oxygens. So the formula would be N2O5. If I had, for a second example, iodine trichloride, iodine is I. There's no prefix in front of it. It's the first element. That means there's one of them. Trichloride means Cl3. So that really is everything you need to know about naming molecular compounds. There are other molecular compounds that we are not going to learn how to name. There are lots of them, actually, and we're not going to learn how to name any of them. The only ones we're learning to name are binary molecular. Now, the other thing you'll notice is that if you have two nonmetals, you do not use Roman numerals ever. Do not use Roman numerals. You use prefixes and only prefixes to name these things, or to write the names of these things. And Roman numerals never ever appear in formulas either for ionic or covalent. So when we start looking at naming, there are 4 substances that have common names that you need to know. They do not really follow any rules. So everyone knows H2O is water. That's no big deal. NH3 is ammonia. And don't confuse that with the polyatomic ion NH4+, which is ammonium. So those are 2 different things. NH4+ ammonium, NH3 ammonia. CH4 is methane. That's the stuff that we use to burn for Bunsen burners. That's what comes out of your stove. Natural gas is methane. And then NaCl is table salt. So specifically, there are other types of salt. The one that we use on our food is table salt. That's NaCl. I'm also going to talk briefly about acids. We're not really going to do a lot with acid naming. I just want you to be familiar with how things work so you understand it when you see it. So first of all, we know that something is an acid because it has H+ in it, which means that the formula starts with H, as you're going to see in a minute. So all the acids you're going to see, the formula starts with H. So if I have a binary acid, that means 2 different elements. I have an H+ and a nonmetal. If I have something called an oxyacid, that's also referred to as a ternary acid. So these are just terms, oxyacid or ternary acid. They have an H+, and then they have a polyatomic ion attached to them, and that polyatomic ion has oxygen in it. Thus the term oxyacid. So when we go to name acids, if the acid does not contain oxygen, which means if you were just to name the negative ion by itself, the name would end in IDE. We add a prefix, hydro, and a suffix, ic, to the anion. We do not use, and then we use the word acid at the end. So we never use the word hydrogen in the name of an acid. So for example, HCl, if I were just to write this as an ionic compound, I would call that hydrogen chloride. So, but since the H is in front, that means it's an acid. So HCl is actually an acid. So there's no oxygen in there. So I look at the anion, the negative ion, which is chloride. I give it the prefix hydro. So I say hydro, chlor, and then I change that IDE ending to IC. So that would be hydrochloric, and then the word acid. So hydrochloric acid, if I had fluorine instead of chlorine, it would be hydrofluoric acid. This also works, even though this is a polyatomic ion, this is one of the ones that ends in IDE. So that polyatomic ion is cyanide. You notice the ending ends in IDE. There's an H in front. This is an acid, so to name it as an acid, I take the name of the anion, cyanide, put a prefix in front of it, hydro, cyan. Instead of putting IDE, I put IC, hydrocyanic acid. So anytime we have acids that don't contain oxygen, they're going to have the hydro prefix. So the hydro prefix indicates that this is an acid that does not have any oxygen in its formula. So what happens if it does have oxygen? Then we don't put a prefix. We only put a suffix. So, and the suffix we put on it depends on whether the ending of the anion is ATE or ITE. So, for example, HNO3. This tells me it's an acid because there's an H. NO3 is nitrate. So when I go to name this as an acid, no prefix, but I call this nitric. Change the ATE to IC, and then the word acid. So the nitric with no hydro prefix means it's a polyatomic ion. If I had hydronitric acid, that would mean H attached to a nitrogen, or H is attached to a nitrogen. H2SO4, again, this is sulfate. This one I want to show you because it's a little bit different. So I go to name this as an acid, no prefix, sul, there's sulf. Now sulfate is a little bit different because instead of just putting ic here and calling it sulfic acid, it's called sulfuric acid. So, but you still have that IC ending there. So sulfuric acid is H2SO4. Works the exact same way for ITE endings, but instead of using ic as the suffix, you use OUS. So if you look on your chart, NO2 is nitrite, which means that as an acid, this would be nitrous acid. OUS, because the ending of the ion is ITE. IC ending, because the ending of the polyatomic ion is ATE. So last example, SO3 is sulfite. So ITE comes off, OUS comes on, but it does the same thing as it does up here. That would be sulfurous acid. Okay, so again, I gave you some practice to work on. We're not going to spend a lot of time with this, but you just need to be familiar with how these names are put together for acids and be able to recognize that it is an acid. That's probably as important as how to name it, as to recognize the fact that if it starts with H, I am dealing with an acid.